So, without further ado, it's a pleasure to have Sophie and Ruchir here. One of these persons is my Uber boss. You can guess who it is. And actually, I would just hand over to you. And
okay, perfect. And so, Ruchir Puri, the chief architect of Ibm Watson platform for business and the AI, leads AI software development team, and I will lead this session with you guys, which is fantastic. I'm Chief Operating Officer for Ibm Research, which means working with labs around the globe. We have 12 labs around the world, including here in Cambridge, Massachusetts. And I live in the Boston area, and I joined IBM less than 6 months, about 6 months ago now. I need to keep counting here. I was the head of research at Xerox Corporation and CTO at Xerox for 11 years, previously also with labs around the globe. And IBM Research is just a totally amazing organization with significant focus on AI, including machine learning. So when Hendrik invited me to speak at this now meetup, I was very delighted to do so. But first we had some really big news today. If you maybe you heard it, today we announced the MIT Ibm Watson Ai Lab, and here you can see the researchers. These are just IBM part of it, celebrating with some champagne that Hendrik himself brought in today, which was fun. But we have an agreement to jointly with MIT build the MIT Ibm Watson Ai Lab. It's currently a 10-year agreement. The goal is that it is sustainable. Anybody here from MIT? Yes, two. Excellent. So it is a long-term relationship. It's focused on AI. IBM is going to invest about $240 million in this lab, this new lab, and the research will be jointly performed between IBM researchers and MIT faculty, students, and the areas of AI, core AI algorithms, the physics of AI, the hardware for AI, applications of AI, preliminary in healthcare and cybersecurity, because we are here in the building where also the IBM healthcare business is headquartered, as well as IBM cybersecurity business is headquartered, and the IBM Watson Cloud business is headquartered. So there's a lot of great activity happening here. And of course, the research lab is here on the second floor. Do we have more chairs? There are chairs on the other side?
got all of them.
You got all of them?
I can
go
hear some
find
from
some
the
chairs.
Okay.
Yeah, out of the other rooms. Yes, and some of you without chairs, you might want to run with them. And so, anyway, this is really great news. And as a result, we are indeed hiring, because we are going to hire about 40 AI experts, in addition to the lab, the people in the lab that we already have. So if any of you is interested, let us know. So at IBM we solve really hard problems that can make and will make a difference to the world. And whether it's in healthcare, energy, related to security, education, the environment. I mean, it is focused on AI and on blockchain, on quantum, some really breakthrough technologies, but focus on really fixing big problems and making a difference to the world. That's the main reason, or two reasons, why I joined IBM is the fact that really the diversity of the capability and the people, right, working in many, many areas. These are some of the core areas that we do research in, but also being able to really make a difference to the world. And the third reason is it's just a very inclusive, diverse company where anybody can really be themselves. So we have a broad variety of core disciplines that all come together to then go solve some of these big problems. So, but today let me focus on AI. As we all know, AI will ultimately, it's a buzzword, but it is real today, and it will become embedded even more so in the fabric of everyday life. And with that, we are focused on AI for business. Right? IBM is a business-to-business company, but ultimately our clients serve in a personalized basis their clients. So whether it is helping a doctor provide personalized healthcare to a specific patient, or a teacher, help a teacher provide personalized education to a specific student, or whether it is in financial services or with governments helping individualized citizens, So it's all about being able to personalize. And you cannot personalize at scale, meaning touching millions or more people providing personalized services, unless you have significant and accurate insights about these individuals, as well as have automation and be able to really automate. And so AI is a key enabler to really provide personalized, individualized solutions at scale. So let me show you a few of what we're working on. Today, this is, I say today, what means today, it's commercialized today, it's actually run out of this building. We work with physicians all over the globe to really provide knowledge and capabilities to much more quickly diagnose diseases. And you can just, so for example, instead of having to go through 10,000 images or many, many images, ultimately the system returns like the top 20 you should look at as a physician. So this has been in the market for a while. Some of the really breakthrough capabilities now that we are working on is finding, this is in research, not only looking at images, patient records, etc., but also bringing in things like genomic data. In fact, we have also collaboration with the Broad Institute between Harvard and MIT, that's also located right a couple blocks from here, to really bring the human genome into being able to provide personalized care. In addition, in our Augmentation lab, we have a significant research program in the biome, the human biome, and the biome of many, many other species. Like we formed a food safety consortia where we work with companies like Mars and other universities like Cornell to understand and track and quickly be able to assess any food safety related issues based on the biome of what's in the food, basically. And so it is going well, and of course analytics as well as potentially AI to be able to quickly personalize and understand, get insights out of the data, and then have physicians, give physicians the tools and the capabilities to use it to personalize care is just very important. It can make a big impact. Another one is, for example, and this I wanted to switch to the Internet of Everything, right? IoT with smart devices, smartness embedded all around us. Also an example in healthcare. There are several other examples the researchers are working on. But this is in the Yorktown Heights. We have something we call, I forgot how the house is called, but next to the research lab, we have a real home that's all instrumented as a house where we can observe patients. We currently have a big partnership with one of the pharmaceutical companies to assess Parkinson's disease and Parkinson's care. So we work, what is the influence of just how does the patient behave as a daily life? I mean, their sensors in chairs, in the bed, I mean, all around the patient. We look at how they walk, how they, basically their behavior on like they stay weak in this house, and we can observe them, how medicine has an impact on how they behave, etc. And so it's very important to individuals to really understand how can we have better treatment for patients with Parkinson's, for example. But some of these technologies you can envision as is being done to have remotely, like in elderly care or older people, of course, who live alone, or across the board there are many, many applications of really instrumenting a smart home. So moving from the IoT for healthcare, another at a higher level, and in fact I was just talking about it with you, yes? It's really ultimately instrumenting the planet, right? Not only at the home level, but across the board. There is so much data and information that is gathered. In fact, David Kenny, who's the head of our Cloud Watson business, headquartered here, he came with the acquisition of the Weather Company. As you might know, if you've been looking at your Weather app recently, that is owned by IBM, but they came with an amazing platform, an amazing amount of data, and then connected to a huge volume of sensors all over the planet. But in addition, we look at satellite data, a whole bunch of other data to really understand and ultimately be able to have a positive impact with clients in agriculture, in the energy space, and have a positive impact. One of the projects I'm really personally a huge supporter of, I was in the China lab recently, is having worked with Beijing, where there's a significant issue with pollution. The researchers installed like 2,000 something 2,500 sensors all over the city, so that on a real time we can measure the pollution levels in the city and leveraging some of the prediction algorithms to understand what is pollution going to be 10 days from now, combined with the weather company data and projecting what's going to happen. And then the city officials, the Environmental Protection Agency, has this rolled out, they have this beautiful war room where they can totally track the pollution levels in the city, and then can send out crews to potentially stop at a very local level. I mean, the sensors are really very localized, understand what is pollution, what is happening, what is predicted, and then be able to reduce pollution. So overall, this solution has been able to reduce this is particle size 2.5 micron and below in the air significantly, which really makes positive impact. And now it's deployed across many cities in China, and businesses been formed, and it's being rolled out pilots in North Korea. It's sorry, South Korea. And across, I think, in Africa, where we have a lab, in Latin America, so it's really rolling out. And I think in some of our cities, we can also use some of these solutions. Anyway, then deeper insights through better technology, right? It's not only the algorithms, it's not only the big data, so it's both algorithms, data, but now also really much more powerful hardware. We're all used to the GPUs, right? I mean, NVIDIA, other companies, they have powerful GPUs on which AI training is being done today. Well, in the labs, we're looking at a variety of other hardware, including brain-inspired chip design and approaches, and in fact, again, in the lab in Almaden, as well as York and in Zurich and Japan, for many years now, have been looking at designing specialty chips, everything from TrueNord, many years ago already, to other applications, but really looking at these specialty deep neural network chips. The way I look at it, it's really, they take images or sounds or smells or whatever it is, take it in and then really create some more structured information that then can be reasoned upon or created insights from, triggering workflows, etc. So really exciting work, and again, we're going to accelerate this even more now with the partnership with MIT. In addition, for also many years, in fact, I was 25 years at Xerox Corporation, but my very first job was in IBM research. It's like coming home out to Yorktown Heights. And even back then, we were working on super low temperature semiconducting. My PhD was in microelectronics. So I was very interested in some of the work that now ultimately is leading up to quantum computers that are online now. You can go to the web and in fact start experimenting. I think the 5-qubit and even the 16-qubit we have announced, and it's available on the cloud for research. The researchers all over the world, if you're in this space, we've done 2 million experiments that have been run through the cloud on this computer, quantum computer today. It's very early. We have no clue what all the applications will be, that startups are working with this, that are really could come out of this new computing capability that will pretty soon exceed, once we get to the 50 qubit or more level, what traditional computing can do for you. So, new horizons for AI. One of the exciting things is creative AI. This is a trailer that AI has created for the movie Morgan. This was created by one of our researchers. Oh, sorry, I'm going the wrong way. It's not loud enough. Oh. Yeah, here it is. So it's a trailer created by the AI system. So looking at what are the top scenes in the movie, and
it exceeds our wildest expectations.
Nice to meet you, Morgan. Nice to meet you, babe. I have a 13-year-old daughter. You don't get to see her much anymore.
Skip, don't go in there, okay?
Oh, what?
Don't you go down there, Skip!
Don't be afraid, Amy. I have to go say goodbye to Mother.
okay, so I'm gonna stop this. Oh shoot, Again, I don't know. Oh, this is, yes, so next will be Ruchir. But as you can see, normally making a movie trailer takes a long time. Individuals manually go through the movie, understanding what are the scenes that will attract the most people to actually go watch the movie. So we worked this with the team. In the end, I compared what we did versus what actually was the movie trailer. It was still different. They didn't exactly take what the AI, Watson AI came up with, but these are the kind of capabilities that creative AI really can start doing. We have a Chef Watson is called, coming up with new recipes. I mean, I know some of you are working actually in startups looking at really what else can AI, once you generate new knowledge, generate new information, generate new code. I mean, what else are the possibilities going forward? So that is a high level overview. I'm going to hand it over to Ruchir, who's going to go now to the next more techy level, and then both of us will be happy to answer questions. Yeah, great, thank you.
I work for a company called Optum.
Yeah.
So, in regards to the movie trailer that's generated by Watson, I'm curious what sort of feature set was, or what sort of features were utilized to determine what was an engaging scene for the ad.
So that is a very good question. I will ask Ruchir because he might actually know the technical details of exactly which features, but I think the notion was the most maybe suspense, maybe sound. I mean, there are many things you could potentially realize.
So the model is actually trained on, so it showed full movie, and then it's shown the trailers, and it learns the features, and then you are shown a new one, and it is able to create it. So it's more of a learned model, as opposed to features are specified, features are actually learned.
Oh, okay.
So that's what John Smith does with this trailer.
Yeah.
Could you also envision that in time the movie trailers will actually be dynamic, whereas depending on
Personalized?
Personalized, yeah.
So if I go to look at a trailer and it knows my history of watching on whatever, it just
We should
kind of
talk to
generates-
Netflix about that. I mean, they can give us some additional insights. You're right. That's good. That's good.
Again, I'm Watson architect, so my job is to be closer to the ground, actually. So I'll not speculate. My job is to.
No, but I'm speculating.
Well,
I'm
that's-
research.
I come from 20 years of research
Right,
background.
too.
However, again, I was drafted over to Watson. I call it a draft, actually. So after 20 years of, I was having, just from a background point of view, I spent 20 years after my PhD in research down in Yorktown Heights at Ibm Watson Research Center. Every 3 years I take a sabbatical at some of the nice places. So I was at Stanford last year in summer doing a sabbatical at the computer science department as a visiting faculty. And I think Arvind, who is head of research, and David Kenny, who is head of Watson, was too jealous of me, so they drafted me too. They called me up and said, "You have a new job." And I said, "Do I have an option?" And they said, "No, you don't have an option." That's why I call it a draft, but I'm having fun, actually. It's a blast. So I'm going to talk really about, give you a feel of, a lot of you have heard about Watson. I'm going to give you really a feel about where we are today, from a very technical point of view, where we are going, and how some of the narrative that is out there. I'm going to define problems like cats and dogs, and my cousin Vinny, and why businesses AI differ from what I would call perceptual AI and consumer AI. So I'm going to really differentiate between, so feel free to ask me questions. I'm really going to call the contrast out between business AI and perceptual AI, or what I call consumer AI, and what kind of techniques you need in this area to be successful. Because I firmly believe if AI were to be successful, businesses have to embrace it. And business problems are downright dirty, actually. Some of the businesses, a lot of businesses I would argue, are living in stone. You could argue in stone ages. So that's reality, just get over it. You cannot say, I've changed your way of doing things. You have to really move them over. So I'm going to take you through that transition, what those problems are, what the algorithms needed are, and what successes we have had and what has worked and what has not worked as well, actually. So I'm going to take you through that. So just from a point of view, I start from a more messy chart, because life is messy. Watson is actually what we call a 4 C's architecture. It's built out of cloud, which is right at the bottom there. We have what we call a content layer, right, built on top of it, known as the data layer for us. Right above it is our cognitive and compute layer, which is also known as the AI layer, the layer I'm responsible for. And right above that is the applications. We call them conversation applications, but conversation not in terms of chat bots, but more in terms of how you interact with the system actually. And there are various set of applications built on top of it. So right at the bottom is what we call infrastructure as a service. So this is basically where all your global WAN backbone is, hub and spoke regions for the data centers and hyperscale data centers. Watson is pretty much deployed across the world in various data centers. Watson is available in the cloud, you can go and feel it. My goal is really, and I personally do this, I've been coaching a team of 4 or 5 5th to 8th grade girls who do robotics. Many of you may be familiar with First Lego League. They have a research project component of First Lego League robotics. And for last 3 years, I would say, more importantly in last 2 years, we've been doing projects with Watson. These girls are, some of them are 5th grade, some of them are 7th grade. All they know is Python. They know nothing about AI. Absolutely nothing. They don't have a clue of what machine learning is. But my goal is for them to consume Watson, and kudos to these girls. The project they did last year, which was on, the problem they tackled was on collision of birds with windows like this. I don't know how many of you are familiar with it, but it actually was on visual recognition. Making it a deep learning model that is able to recognize birds coming and be able to sound alarms actually, to deter birds. And to be able to use Watson to train it. And that, to me, the level of consumability of an AI system, including Watson, I would say. I'm not here to sell Watson. Ideally, it should sell by itself. I'm not in marketing at all. But the point is to be able to have a level of consumability where it should not take a damn machine learning PhD to be able to consume it. Otherwise, the level of penetration of AI will be very, very limited. I think many people in this room are too high achieving. It needs to get down way below actually these floors for AI to be consumed. Okay, so really the first level of layer is really what we call infrastructure as a service. So we've got hardware, we've got security services, virtual compute, VM, bare metal right there, virtual network and networking services, block file storage services, object store. This is pretty much deployed across the world in 6 to 8 data centers and scaling out massively as well. We rely on Kubernetes as what we call a container OS to manage resources, deploy resources, schedule resources. That's one of our fundamental operating system on top of which Watson is built. We've got data services, relational databases, key value stores, elastic services as well. We've got logging, metrics, autoscale. You're going to need all of this. This is what I call the layer on which Watson is fundamentally built, on which you are going to build your algorithms and scale out your algorithms as well. And then on top of it is our application services, messaging, billing, entitlement, and the kind of things most of the research people would not think about. Billing is not my problem. My problem is to invent algorithms. Unfortunately, that's why I call it drafting actually. I never thought about this before, but you get into a new job and this is your job. A customer comes in, you have to account for how much time they use, what they use, you have to bill it actually. When I was developing algorithm, which was 20 years of my life, I never thought about this actually, that you have to bill someone. And obviously developer services that go on top of it. So this is basically the foundation of Watson. Right above it is actually what we call the data layer. So from a data layer point of view, we actually have, so one of the fundamental aspects of Watson is, which differentiates it from actually I could argue our competition is, so we take 3 levels of data. Let me specify what I mean exactly by that. So number 1, Watson should understand the world around us. So So for example, Wikipedia kind of data. Everybody has access to it. Watson should know, what does the office mean, what are chairs, all kinds of stuff actually, which is general knowledge that you can go to Wikipedia and get knowledge from. So that's one level of data source. The second level of data source is really about what I'll call domain-specific knowledge. If you are, for example, in finance industry, there is a lingo of finance industry that everybody speaks. Watson should be aware of, finance industry lingo. If you are JP Morgan Chase or if you are Bank of America, you shouldn't be coming and teaching Watson finance from scratch. Everybody in that industry should understand, Bank of America comes and, they should teach Watson their own lingo, but they should not be teaching Watson what's a stock, what's a derivative, that it should know. So that's that second level of model, which we call domain and license models. And the third level of model is what we call private data, which is your data is your data from an enterprise point of view. We do not use your data to benefit someone else. I'll make it even more concrete. And I think people in finance will certainly sympathize with me on this, and other industries as well. Bank of America does not want its data to be used to benefit a machine learning model that was built, turned around, and deployed on JP Morgan Chase. You can very well imagine, they might be a little bit upset about it, as will be Verizon with respect to AT&T and other competition. So you really want to make sure your data is your data, while you do get benefit of what I call two levels of data models, which is public data models and domain-specific data models. And the third one is sort of private models that hang off those kind of data models. So that's where we go and really accommodate private and public data sources. We have knowledge kits in many of our services, and we are ramping that up as we ramp Watson more. Like banking, we have starter kits, knowledge kits related to it, and so on. Then so basically you go ingest the data, and many of us who play with this on a daily basis, and it's reality. Actually, interestingly, most of the time consumed in developing machine learning models goes into the data prep. It's a reality. Algorithms are the ones that get most of the attention, but the most of the work actually goes into making sure that data actually fits in the damn algorithm. Specifically, people who do vision will sympathize with me on this. You really end up struggling with OpenCV functions most of the time. It's not the damn deep learning algorithm where you end up training. You really are trying to figure out resizing the images, getting the right unit functions and so on. That's what you end up struggling with. And there are equivalents of this in language and other areas as well. So we've got capability to really clean up the data. This is where AI really gets involved, which is what we call enriching the data. So really ontology, rules, machine learning, deep learning, all kind of stuff gets involved here. And the AI functions of this is actually what I'll talk about a little bit after this. And then finally you go and enrich the data, and you go and store that enrichment in knowledge representations. Knowledge graph is one kind of knowledge representations that we have. Each of the AI step is actually broken down into 4 steps. One of the things that Watson is actually built on is, Watson is a microservices based architecture. Everything is built out of microservices. It's really a cloud native architecture. As some of you know, cloud native architectures are built out of microservices. We have got microservices that actually comprise the curation of the training data. We've got a train architecture, including deep learning as a service, which is part of it. We've got a serve architecture, and we've got data analytics and usage that we are trying to build up now as well. And then as you refine, as new data comes in, there is a loop that continuously improves that model as we continue to actually learn and improve our machine learning and deep learning models. Right on top of that is built our APIs that you, I, or anybody can go and experience. These APIs are basically the ones shown in green. The one which actually are more enterprise-centric, I would say, are conversation, discovery, compare and comply, and I'll talk about them a little bit later. Retrieve and rank is more about documentation retrieval, which documents are relevant to what I'm really looking for. Emotion analysis, tone analysis, personality insight is what I call perceptual APIs. We've got visual recognition, speech to text, text to speech, natural language understanding, natural language classification, and deep learning as a service, which is one of the services we are bringing out externally as well. But we consume this internally for our doing deep learning for several of our functions as we ramp up. Right on top of this, so basically these APIs, the one in light green, they are available in various SDKs for us. So they are available in Python, they're available in Java. You can go and consume it in your applications. This is basically what we call developer-facing APIs. Right on top of this is basically some of the applications we deploy for enterprises. These are packaged applications that are available for enterprises. Watson for Oncology is one of those applications. Watson Cybersecurity, which actually utilizes discovery for it to get the AI inside cybersecurity applications. We've got Watson Virtual Agent, which utilizes conversation. We've got Explore and Discover, which actually uses discovery again, and Compare and Comply, which actually uses our Compare and Comply API. So these are next set of higher level applications that actually has, you don't need to go and use the APIs for them. You basically have, these are enterprise applications that are available for deployment for you. So the key strategic focus areas, as I went through this already, for us are sort of a strategy around content. I already talked about it, training strategy, our scaling strategy, and our scaling strategy is in multiple dimensions, including language scaling. As you can very well imagine, Watson is basically deployed in many countries. It needs to speak the language of the country it is in. It is critically important. And then we have reasoning strategies around transfer learning, few shot learning, and summarization, and I'll talk about them a little bit more. Now, this is where it gets interesting, and I'll get into cats and dogs syndrome now, actually. How many of you can sort of realize, and most of us may be able to, what is that on the left-hand side? So that's actually an insect, obviously. So if I didn't tell you, what was there in the sort of top middle section? Most people will get confused with it because nature is just phenomenal. And this is Watson. And again, I'm not going to beat my chest on because I don't want to beat our chest on, we can nail insects and, that's not what Watson is about. Neither it is about chatbots, not at all actually. And that's where I take you through why enterprises are so different. They're not about chatbots actually. It's very different than what Facebook may be trying to do. It's just a different problem altogether. Now, interestingly, you can see, that's a stick insect, and that's cool. It's literally a feat of engineering to be able, for a computer to be able to nail that was a stick insect. Most people might get confused with it if not shown that middle top portion. However, I would say, yep, that's cool, and that's the kind of stuff, the past version of me in research gets all excited about. But I've been drafted, so yeah, I get all excited about, but that doesn't pay my salary anymore. So this is cool, but really businesses need what I call beyond cool. This is another example of it. This is actually an entry into a Microsoft Coco challenge. They run actually image captioning challenge. These are 3 images. Obviously, they're not. If you ask a computer to label an image, it's not an easy problem. You can very well imagine because you need to know the context. And this is Watson again. A blue boat sitting on the side of a building. Oh, not too bad actually. A green bird sitting on the top of a bowl. That's pretty good. This one is hard actually. A woman sitting on a table with a giraffe. Now, I could argue shouldn't be with a giraffe because giraffe is outside. and she's not sitting on the table exactly either. But not too bad actually, given that it's a black and white image and you can't exactly see the women either. Totally. This is hard actually. And it's amazing what, where AI has come with respect to technology today. Now this is vision, keep that in mind. But really, you need much beyond image captioning accuracy as well from an enterprise point of view, and that's what I'll illustrate as I'll move on. So, in particular, deep learning methods have had a profound impact on a number of areas in recent years, image understanding and speech recognition. This one. Natural language processing and classification, conversation and dialogue, biomedical image analysis, and the analysis of sequential signals in a variety of application domains. However, I think from the point of view of as important as deep learning algorithms may be, I think their impact is largely limited to, and I'll tell you why exactly, to what I'll call perceptual AI. The problem of enterprises is quite different. So let's look at where the speech models are today. So basically speech models are at a level of, we got hidden Markov models with deep neural network systems. Basically, what you can do now and what Watson can do is really we can customize speech models. My accent is certainly different. Someone else's accent may be different as well. We can customize speech models for you. We can build, you can go and train Watson more incrementally, and it can build a speech model for you that's more customized for you. That's one of the things we can do with where we are today. We are working towards, obviously, end-to-end neural network models, phoneme-based models as well. The papers are out there, you can go and read it. This is not a private information I'm giving you. We publish papers and research in this extensively. We are actually, obviously, on some of the benchmarks we do very well. Again, I don't want to beat my chest on benchmarks because benchmarks are benchmarks. They are not reality. You should go and try it, see how it works, and really make your own decisions about it. And again, we are also working on truly end-to-end CTC world LSTM models, again, neural network models, as we head towards more of scaling out technology from a deep learning point of view on neural network models. Another thing we have done, you might have seen more recently, IBM making an announcement on a deep learning breakthrough. Some of the things that we have done is, as deep learning problems become bigger, so either there are two ways deep learning problems can become bigger. One is the data sets become very large, and I'll talk about it. So just to give you an example, maybe I'll postpone that a little bit later because I think it's illustrated by the next one I'm going to talk about. Deep learning models can become bigger in two ways. Number one, the data can become bigger, or the networks themselves can become bigger as well. So I've seen more recently networks, that are hundreds of layers deep. There's talk about, 1,000-layer deep network. Now, to me, that is really brute forcing the problem. It's overfitting the problem, brute forcing the problem. But I'll leave that aside for the time being. But so what becomes important with that large size a problem is you cannot handle the size of the data and the size of network and train it in any reasonable period of time. So what we have done is we actually, the team in research came through a breakthrough that is able to train the ImageNet data. I don't know how many of you are familiar with ImageNet data set. It came out of Stanford from Fei-Fei Lei's group. It actually has around 14 million images and 22,000 classifications. Most of us, and in fact, I'll challenge anyone to really recognize all 22,000 categories. Because it's got hundreds of dogs categories, I probably know 2 or 3, not more, I don't know. I'm not an owner of dogs, so obviously I recognize lower than probably others here. But most of the humans cannot get much of it. The best human accuracy is around 20%. And by 20%, I mean top 1 accuracy, what I call top 1. You need to nail that particular category. You can imagine among 22,000, it will be a hard problem. Now, computers have come to, the previous record was 29%. Not bad for a computer. The work that was released most recently by IBM Research can do that. So this was done by Microsoft. The last benchmark was 10 days. The one that was announced recently from IBM Research was done in 7 hours. And I'll tell you why it is important. And the accuracy was 33.8. Now if I just gave you a number, 33.8 versus 29, you would say, 4%. It's okay. The 4% is, by the way, 4% of, or roughly 4.8% in this case, of 14 million is a large number. It's larger than 500,000. So if I told you I can recognize 500,000 images more and nail them actually, I can tell you in one shot that is what it was. you probably will start paying attention more. 4% doesn't sound that good. And by the way, keep in mind, that is the tail of you are pushing the boundary now. Those are not the low-hanging fruit anymore. Those were harder ones that you were not able to get before. You are already able to get the low-hanging fruit already. So that's an easier problem. Now if I tell you if I can get 4.8% more, which is 500,000 images more, and I can nail them, that is, I think you probably will pay a lot more attention then. And that is exactly what was done. And that was done in 10 days versus 7 hours. Now that's the kind of work IBM Research and Watson is really focusing on. But again, this is all related to image accuracy. So yes, we do images, yes, we do speech, yes, we do chatbots also. But again, Watson, I think as Sophie started the discussion, is AI for businesses. Businesses are a lot more than chatbots and cats and dogs and my cousin Vinny, and they're a lot more than that. So let's talk about exactly what they are. So as good as deep learning may be at recognizing patterns in images and AI, today I think we certainly know that the deep learning methods have limitations. So let's talk about those limitations. So here's an important one. And I'll illustrate this with, most of you are very young to have, probably maybe some of you have kids, but many of you are very young to have kids actually. I have 2 daughters, 16 and 12. And when she was very young, I had maximum 2 or 3 books of A's for apple, B's for boy, C's for cat, not more than that. And when I was teaching her, one day I'll teach her, and maybe other day my wife will teach her, hey, that C is a cat, and maybe after a couple of weeks, we show her another picture of a cat. She says in a cute voice, that's a cat. Now I'll give you a contrast. A deep learning model with ImageNet has 22,000 categories, 14 million images. That's roughly around 700 pictures of cat to recognize a damn cat. Just think about it. If I ever showed my daughter 700 pictures of cat when she was 1 year old, she's 16 now, she'll not be able to recognize till this day that's a cat. So there's a fundamental difference between, I think, where we learn and where sort of the brute forcing of deep learning is. Again, to be truly honest, I'm in awe of where engineering is today. I'm no way minimizing the advancements in deep learning. We are doing that ourselves. However, there is a problem in the way things are being learned. You are brute forcing the problem. Now I'm going to make that problem more real, actually, I would say. The reality of the problem is, so ImageNet came out of Fei Li's group, done by Olga to a large extent. And so Fei has a whole group of large army of graduate students. Her constraint is she wouldn't let the graduate students graduate until they labeled the 14 million images. For most of you will sympathize with me, that is a good enough motivation to label the images. It can certainly be done and done very fast if I really want to graduate actually. Okay, so that's a good enough motivation. Now interestingly, many of the images data can be outsourced to mechanical terms. We all know it can be done. Take KPMG as an example. Or take JP Morgan, as an example. That's classic large enterprises. I want to label what is the risk assessment of a particular instrument. Am I going to outsource that to a mechanical Turk somewhere? Assuming I can, just assume so that I have no privacy concern, all my data can go outside, I made the problem very easy. Most of the people in the world wouldn't even know how to label the damn stuff actually. That's where I call it a cats and dogs syndrome. And yes, I know I'm trivializing the problem. Yes, I'm trivializing it to prove a particular point. The point is that the enterprise data cannot be outsourced that easily. Most of the people do not even know how to label that data. In fact, I could argue there are not that many people in KPMG itself that can label the data actually. There are 5 to 10 people in KPMG who can label the data. So therein lies a problem. Learning from big data versus learning from small data. So I hope you can realize the problem is in real world, at least in enterprises, is not about learning from big data. It is learning from small data. The world and enterprises have infinite amount of data, correct. They really have infinite amount of data. They do not have infinite amount of label data. Unfortunately, AI techniques today are stuck at labeled data. Until we make a fundamental advance in AI techniques that they learn without labeled data, you are stuck. That is why I think that's where lies the contrast between AI for businesses versus what I call my cousin Vinny. You know, you didn't label my cousin Vinny right on my phone. You know, I may be upset a little bit. Yes, it's fine. It's okay. I'm going to actually go to another more important point, which becomes even more important, I would add. So, okay, so that was cats and dogs. So let's go to the next one. So this is actually, so Watson, we've been focusing on, so that I wanted to say, you know, our focus is not necessarily learning from large data, but learning from small data. And this is a comparison done by a company outside, not us. And you should go and try it yourself again. I'm a big fan of things should be out there, you should try it. I really hope we are trying our best that it will really work well. Sometimes it may not, it's possible, this is engineering. But I really want you to go and try things and try things out. This is actually on the x-axis is number of training samples. On the y-axis is accuracy. I think this is really being compared to Amazon API.ai, Watson, Microsoft Lewis, Recast, Bit.ai, and Snips.ai.
Can't read it.
It's there out actually. That's why I can actually, what I can do is I can just give the website. You can just go and look at the data. This is not our data, actually. This is our data outside. But this, again, I'm telling you, Amazon, API.ai, Watson, Microsoft, Recast, Bit.ai, and Snips.ai. And the right at the top is the curve for the Watson. If you draw a line for a accuracy, roughly we are taking half the data that it will take. And again, this is our focus. The reason is not that we ended up on that point by fluke. We really are trying to design it so that we take less of a data. That is the situation we are in because the enterprises actually need less of a data. Now we are focused on, this is again not to beat our chest on it, we really are focused on really learning from smaller data. One of the things we really do is, you know, can we transfer the learning over? So given a learning in a let's say I do learning in a particular workspace here. Now if I'm learning a new task, could I transfer that learning over? So just like what humans do, you never learn from scratch. You are always building on the experiences you have. That actually area is called transfer learning, and also called, you know, few shot learning as well. So another problem that we are focused on to a large extent is basically, you know, moving or transferring the learning over. So one of the things we've been doing, this was a paper that was written by IBM Research recently, again on our archive as well. We broke the problem into what we call a meta learner and a base learner. The meta learner operates across tasks used in LSTM based models. The base learner exploits matching network and parameterizes the task metric using weight prediction from the meta learner, so they learn with each other. One of the things we have done is we are able to show that yes, this is all in research, but we are able to show yes, we can achieve pretty high accuracy using those transfer learning approaches as we move forward in our research. Again, all of this is there in the archive, being published as well in the literature too. Let me move on to the next challenge for enterprises, which I think deep learning models, technology as it exists today misses, and what we are working towards, which is on what I call a reasoning challenge. So, interestingly, I already talked about, you know, the data side of it. The second part of it is, and I'll illustrate that with an example. Some of you have heard me give this example before, so you may have to bear with me on this. But let's say I'm in a business of, you know, buying houses or anything, trying to buy anything, but you don't have enough money to buy it. You know, the blessings of the Western world are you can always get a loan for anything actually. Whether you can afford it or not, let's leave that aside. You can get a loan for it. Now let's say I'm in the business of buying houses. We go around, me and my wife look around, and finally we find a house that we like. We don't have enough money for it. You know, my wife tells me I really like the house. I go, okay, honey, I need to go and get some money for it. I go to run to the bank. I apply for a loan, okay? And the guy calls me back 2 weeks later. Mr. Puri, your loan has been denied. Say, what is the first word out of my mouth? Why? Now here comes the punch part, and this is really geeky joke. So for people who cannot appreciate it, you should still have to laugh actually, because it is a geeky joke, and you are in a geeky meetup. So the person says, he's reading off a screen actually and says, so he sees these lots of lambdas on the screen. Lambda is a machine learning vector. It's a feature machine learning vector. So it says here because the machine learning vector lambda is not crossing the threshold of 0.5. And I'll say, why? So I think what I'm trying to really say is, these methods do not tell you why. One of the fundamental aspects of enterprises is, nobody makes a decision until the method damn tells me why. Because if something goes wrong, it can be my fault, okay? You know, my boss is gonna ask me, you idiot, why did you make that decision? He says, the computer told me so. Well, how will that go? But that won't go very well. So I think the point really is, again, I'm bringing enterprises into the picture here. Big data versus small data. So people will say, you idiot, why are you trying to learn from small data? There's enough big data in the world. I will say, no, I don't think you understand the problem. There's enough data in the world, but there's not enough label data in the world. Yes, I'm trying to learn from small data. Other than the fact that my daughter learned from small data, let's keep that aside, as there's not enough label data to be learned from. Second one is obviously the question why. And I think this is one of the reasons I could argue. Then Sophie talked about, yes, we announced a partnership, very large partnership with MIT, is to really work on problems like this. It may appear that the narrative is all about, doing vision labeling and this and that. Yes, and those have made very important progress, but still there are some very fundamental problems to be addressed that enterprises will not embrace AI until we solve the problems like these, the ones I particularly illustrated. The second one is I would really say, and this is where I think it becomes even more clear. So one of the things Watson works on, and you may have seen this partnership quite a bit already. We had a partnership with, how am I doing on time?
Only for 5 minutes. Yeah, good.
5 minutes?
Let's make it 6.
Okay. I can stop at any time. That's okay. So one of the things where we distinguish ourselves on is, so let's take two domain problems. Actually, number one is actually, I'm in London, I'm trying to go from point A to point B, and I want to take the tube. So you really want to optimize your path, given all the traffic patterns. There might be a machine learning algorithm, which is a statistical algorithm that tells me what is the best way to go from point A to point B. Okay, that's, the complexity of the problem in that case is really, difficulty of comprehending the domain. The cost is really the skills and the compute for training and deployment. The depth is sophistication of the analysis. In the case of trip planning, which you may be doing with Google, the complexity is really the London Underground map that I'm trying to really traverse on. The total cost is really, for me in this case, is my schedule change. I really want to minimize my schedule change. And the depth I'm trying to do is really compare different trips together. Now, the second one is, we are working with HNR block. The complexity of the analysis in the Watson case is US tax code. Now you can compare between London Underground map and US tax code. I know our current government is trying to make it simplified. Many people have tried it before as well. But you can very well understand, for a machine to read it all automatically, this is not typed into the machine. It really reads it all automatically. It is not a simple job. That is the comparison between domain A versus domain B. I'm really looking at tax changes, and I'm trying to compare the deductions that I'm trying to undertake. Another important point, and I think this is probably one of the most important ones. If there is a language for enterprises, I would say that language for enterprises, I'll call it PDFs. And because most of the knowledge in enterprises is captured in PDFs, whether they were digitized PDFs or scanned PDFs. So I was at MIT Digital Summit on a panel, and I stated the same point, and another kid actually, I won't name the company actually, and afterwards he came to me and said, why is it so hard to interpret PDFs? That's certainly a good question. Again, I think the kid was too young to do a mortgage. Last time I did the mortgage, so there's a lot of digitized PDFs, all banks have it. They print it out, they have you sign it, and then they scan it in. Now, all the digitized part is gone, They're all pixelized now. So, okay, so how do you interpret a table in a pixelized image? Actually, it's much easier to interpret a cat and dog, by the way, than interpreting a table in a pixelized scanned document. How do you interpret a graph in a pixelized scanned document? How do you interpret formulas in a pixelized scanned document? That's the complexity you're dealing with. I don't want to, I want you to understand there is a fundamental difference between where we are versus where enterprises really need the AI to be, and appreciate that complexity difference and not get hyped up by the narrative that is all out there. It is critically important. There have been winters before in AI. That's nothing new. Summers come and winters come as well. If we are really going to be successful, we should really understand what people need in this area. AI, enterprises are complex, and yes, some of them are in stone ages. You've got to go and adapt your methods for them. They're not going to change just because you have a fancy new startup out there. And yes, some startups will end up changing the world as well. They do actually, as did others too. However, those are the ones that really understood the problem and nailed the business case. And there are certain aspects of these business cases that are more important than many of the people realize in this area. So this, I think I already talked about PDFs. They can be text, they can be tables, they can be images. They're becoming even more complicated. Text is images, audio is embedded in there, videos are embedded in there, and all. So it's really becoming multimodal. And one of the services we talked about, what we really are doing is, this is where we focus on. And I think IBM Research is really focused on this area and helping us a lot in this area, understanding PDFs. We have a lot of focus on it. Now, you might argue, most of the companies don't even bother with it actually. Yeah, we have to, because that's the stuff we are dealing with. Because most of the knowledge of enterprises is in text form, table form, graph form. Yeah, we have to read it. This is not the problem of, nobody who is using this worries about actually, PDFs in general that much. And yes, Watson has to worry about it because the domain it is dealing with. And one of the things we are doing is, this was our compare and comply services. How do you ingest documents? So let's say I'm in an industry that's heavily regulated. Let's take finance as an example. If I'm a player in a finance industry, can you tell me for a particular scenario what my obligations are? Go identify it automatically for me. That's one of the scenarios we are dealing with. Go figure out what are the controls in my company that can satisfy their obligations and map them against each other. So, trying to map what my obligations are, to identify that, what the controls are, and have a really AI model that's able to map the obligations against the controls. If I'm walking on the street and I just catch randomly someone and say, do you think compare and comply is important? And say, whatever the heck that means, I have no idea actually. But yeah, you should ask someone in a regulated industry, in particular finance, do you think compliance is important? That's my life. They'll be out of business if you didn't actually obey something in compliance. So again, I think there's a fundamental difference between what you're seeing in general, perceptual AI versus what businesses need to do. This is my final joke. This is really about teaching machines with small data for AI that explains why. So here is a person that comes in. There's a mound of data, by the way, with matrices that you can see, with some answers. So there's this answer that come out. So this is your machine learning system. The person is asking. Yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side, which is right here. So what if the answer is wrong? You say just stir the pile more until it starts looking right, which is kind of where we are, and we need to go here. I'll just stop here and take questions. Thank you. Yes.
So a lot of what you said in your talk really resonated with me. I'm with a company, we're doing industrial AI. Yeah, sure.
My sympathies with you.
Yeah, so what I was saying is we're doing industrial AI as well. The name of our company is smartvid.io. We're right here in Kendall Square. One of the things we're tackling is how you can understand whether or not workers in industrial environments are being safe by analyzing the constant flow of photo and video data that's coming from multiple. I think I got cut off.
Sorry, it's microphone. It's not that. My question's too long. My question is,
Take this side.
No, we have another mic.
Yeah,
Okay.
you have some backup.
Thought I was being too long-winded. So one of the questions that we continually run up against is this challenge of augmentation versus replacement. So if you think about the value proposition in an industrial AI context, you have to think about how you're positioning it to the business owner and to the end user themselves. And so we wind up, I think, the narrative in the press is often about replacement, but I think the reality is, not just from the technology, but from where most of the value can be realized, is around augmentation. And I didn't see you talk about that. I'm really curious for your opinion of that.
yeah, so I would say that from the point of view of, so let me take two scenarios. Or distinguish between, I'm going to take a customer care scenario, easy enough. And another scenario which is knowledge worker. And maybe the scenario, likely what you're talking about falls in the knowledge worker scenario. In customer care, so there are processes in which enterprises will really like to achieve cost efficiencies. And I know it sounds rude, but there is a triangle, and the base of the triangle on the customer care scenario. May I help you? Thousands of people deploy. In geographies, the people will really like to make it efficient. If there was ever a automated process that automated the heck out of it, enterprises are literally spending billions in that domain. People will be okay with replacement. It's okay. Now, it may sound rude. There are a lot of people in that area, but the execs will be fine with it. I'm being totally honest. Yes, they'll be fine with it. The knowledge worker one gets complicated because they are the one approving what you are trying to replace them. And that's where I do believe, and again, this is technology is as much about science as it is about culture as well. I sincerely believe it, and I spent, I think, almost 10 years of my life automating with algorithms the process of how the microprocessors are designed. You can imagine, the skill in that area was phenomenal. And yes, you have to tread it very carefully. You push and they push back, and hopefully you are making progress forward. So in that case, I would say really the right path to approach for us or for anyone else will be, yes, it is augmentation. And for us, like for example, healthcare area. It's similar area as well for us, exactly. Yes, it is augmentation. And just to be fair, I don't think the technology is there either, to a large extent. Yes, people acquire significant skill in this area. So I would really differentiate. Yes, in some place, a replacement will work. Everybody wants replacement. In other cases, no, they don't want replacement because they are not trustful of the technology. They have very high level of experience. And yes, it will take time. We will get there, but I don't think we will ever replace in that area because there will be experts in this area who can connect many of these things together that at some point we may. It's almost like science fiction at that point. So.
Thank you.
Yes, sure. Yeah.
Fingers crossed.
I was wondering, can you give an example of a problem that could be tackled with a few-shot learning approach in the absence of a lot of labeled data?
So I would say few-shot learning will be like this. So if I'm trying to, I'll make it very concrete. Let's say conversation. If I'm trying to train a bot, an industrial bot that is able to respond in a particular domain. So the typical way of training a bot is you have some utterances you type, and do you say, hey, the intent of this utterance is this. You're trying to classify utterances and what intent it is. And then I type a sentence that the bot has never seen before, and out comes the right classification for it. Now, ideally, my job is to minimize the number of utterances I give to the system when I'm training to be able to train it with a certain level of accuracy. So I'm trying to minimize the amount of utterances and the data I'm giving the system for it to be trained. And in this case, the few-shot learning is all about to be able to take as few number of examples. This is the few part in the few short learning, as few number of examples to be able to train with a certain accuracy. One short learning is about I only give you one example. And in our case, in the conversation case, it's about, one utterance is given to you. Tell me what is the accuracy you can achieve, or can you achieve a certain accuracy if I only gave you one example, in the case of conversation and bots.
So, but the learning must be different then. How does it learn?
Oh, so in this case, we are using actually techniques like transfer learning. So we actually utilize workspaces or models that we have learned in other areas, bring them over, so we don't need a lot of examples in this new area.
Right.
Yeah, maybe you can shortly state your name where you're from. Sure.
My name is Fahad, and I am from Houston, Texas. Well, I'm also from MIT. I'm from MIT. Thank you so much for your talk, Ruchir and Sophie. I had a comment and a question. My comment was more on the black box and the explanation of why, and I really like what you said about technology, so much about culture, just as much as it is about science. There's so much to be said about this black box of like the ethics question of AI and how much reliance we have on it, and I think it's much easier to blame a machine and to be like, it was their fault, rather than blaming human beings. And this whole idea of the explanation of why it's so important now. So I'm really excited for the work that MIT and IBM is trying to do in that field. My question is around, initially, so the Morgan trailer that we saw, you talked about unsupervised learning in that, right? How do you build in creativity, right? Like, if we're trying to move towards this world with unsupervised learning, where is creativity going to come? Or are we just going to see trailers that we've seen in the past 10 decades?
Yeah, I think that's an excellent question. So first, let me take the first part of this question. And I think there are a large number of people, including some think tanks. I was at the Aspen Institute AI Summit, AI Roundtable, and that ethics in AI question was incredibly important. And I think one of the things Sophie mentioned, one of the pillars for IBM MIT Center is actually on ethics
in
of
this
AI.
area. You are with MIT, you mentioned, right? Which department?
I'm in a design program called Integrated Design and Management.
Okay, excellent. Yeah, we are gonna Dave Darter and others at MIT and Sloan School, the economics department, that we're exactly addressing these kind of questions. But the creative AI, we have the amazing research team that's looking at creative AI, and we have worked with artists, with designers, with individuals that, again, it's more like the AI assisting the designers to do a better job. Like there was a great project in Barcelona where we wanted to have a living a piece of art in a museum that's inspired by Gaudi. So the many images from the different buildings, the colors, the textures, were all fed into the system, and out came recommendations of the kind of new art that could be created. And in fact, and something really cool came out of it. It looked like a real piece of art by Gaudi. But in addition, we had also put some strings that the designers themselves said, oh, why don't you make it a living sculpture? And so we had put strings on it, and the sculpture was browsing the social media, like all the tweets, I think, that was going on in Barcelona, and based on the mood of the people in the city was changing the length of these strings that he had put into the sculpture. So it's still, all the creative AI today is in collaboration with artists, with designers, a fashion designer who made a fashion show inspired on, I also believe it was modern architecture, etc. So very interesting technology. So it could be very interesting in this collaboration to do a project in that area potentially.
So I think, just going to the first point, and I recommend that book strongly. There's a real danger of, I don't think you talked about biases yet. There's a real danger of biases in society actually. And as we start relying on mathematical and statistical models more and more. Cathy O'Neill has a very good book on, it's called Weapons of Math Destruction. It's not weapons of mass destruction, but weapons of math destruction. It's a very interesting read. Again, it has got nothing to do with mathematics. Nothing, absolutely nothing. But it's a very interesting read on biases in the society as we start relying on these mathematical models more and more. But I think going back to the creativity point, you start seeing some of it, but again, it's just an evolution of what was done before. The whole area of neural art, where you can actually take one piece of art, and you can take another piece of art, and you can show it to a deep learning program. It combines them and really comes up with very interesting paintings that it transforms it merges two styles together and evolves into a painting that you would say, wow, this is really cool actually. Now, would you call that creativity? It's really merging of two styles. Part of it is creativity. It's not it may be a new style, but still it really derived its knowledge from, and again, my heritage in 20 years in research, I can be philosophical, but what is creativity? We learn all from experiences. It is built on experiences. We can have that over beer, but right now.
Thank you. Thanks for not dodging the question, by the way, around ethics.
Yeah.
Maybe we go for one more question in terms of time limit. I don't want to stretch it. Oh, God. Should we flip a coin? We probably go for chat equality, and you can hand it through.
And I can see your name and where you're from.
Hello, I don't know if this is working.
Yeah.
I'm Helena. I work at Elsevier. I do deep learning for pathology images.
Which images?
Pathology.
Oh, pathology, okay.
Images. Trying to diagnose tumors
Mm-hmm.
and tissue. And I was wondering if you could speak to us a little bit about reinforcement learning, whether you're doing any of that or as part of your small data sets exercise, or is this something that it's not worth?
No, so yes, we are doing reinforcement learning, absolutely. We're deploying most of the techniques that are out there. Yes, we are actually, if you're interested, I'll certainly forward you papers where we are using reinforcement learning. It's a longer answer, but yes, of course we are using reinforcement learning. Yes. I would say partially so, and I'm going to go to a parallel topic to illustrate a problem. So some of you know GANs is a breakthrough in the area of certainly deep learning as well. GANs are known as generative adversarial networks. Not exactly in reinforcement learning, but one of the things with things like GANs, not necessarily with reinforcement learning, is that you basically try to perturb the image a little bit, and you try to find out what is the next iteration of my neural network is going to be. Now, if you're trying to apply things like GANs to a text data, you can perturb a pixel by 0.01%. It's continuous almost. How do you perturb a word by 0.01%? What does it even mean to inject a noise in a word? Words are discrete by nature. Language is discrete by nature. Pictures are continuous by nature. You're trying to take a problem from a continuous domain to a discrete domain. Therein lies the problem. So that's where I think we have had some issues with, I would say, reinforcement learning, but certainly we are using it in various domains actually, and I'll be happy to pass papers on to you. Pardon? Yeah, so you can, I could have gone to, word embeddings, you can do, word to vec vectorized kind of stuff. Yes, but there is a problem between when you really do discrete versus, you can almost go to 0.001% noise in a pixel because it's RGB, combinations are a whole lot. Yep. All I'm saying is not that the problem is not solvable. Only this year I saw a couple of papers, 4 or 5 so far, on the area of, adversarial methods for text, for example. There haven't been a whole lot of work in that area. So again, I'm trying to point out the contrast in the area. That does not mean to say science will not progress. Of course it will progress, but it's just, I think this is a different domain versus where we are trying to address, and yes, science will move as well.
Okay, thank you very much again, Sophie and Ruchir. I think you had a run through from like here to here through AI, so it was, I think, quite intense. Thank you for that. I'm also glad that you came here to this hip new startup with 100 years tradition. And so enjoy the rest of the pizza. I think there are some slices left and some food and mingle and schmooze. And glad to see you in October. Again, we will try to figure out what we do in October, but we'll keep you posted on the website as soon as we finalize. Thanks for coming.
Thank you.